Hello and welcome to the presentation of my conference paper, Computer Vision-Based Web Scraping for Internet Forums. Today I'm going to shortly introduce myself, followed by a motivation and a problem statement, so why the field of web scraping is an interesting field of study and why research there is necessary. This will be followed by the previous work in the field of web scraping, the previous work in the field of document layout analysis, then my proposed approach to web scraping, the computer vision-based web scraping, and the methodology how to implement this approach. Yeah, my name is Eric Dahlmeier. I did my bachelor's degree in data science and knowledge engineering, and I'm currently pursuing a master degree in media computer science. Right after my bachelor's degree, I started full-time work at a spin-off of the RWTH Aachen University, where one of the tasks that I do there is to extract and analyze online opinions, which to some degree also relies on web scraping, which was one factor of motivation for choosing this topic. In addition to my profession, there are, of course, also other reasons why we should have a closer look at the field of web scraping, since there are many different use cases for it, and thus a very robust and generalizable solution would be preferred here. So one reason would, for example, be for scientific reasons. If we conduct studies in the field where you want to gather some data, but sometimes this data is also available online and we want to make use of it. Another scientific reason might be the purpose of dataset creation. So, for example, for language processing tasks, we need to gather as much training data as possible. And for that, we can also employ web scraping. In addition to the scientific reasons, there also are economic reasons. For example, a company might be interested in market or product analysis to see what the customers write about their product or their competitor's product. Of course, also quality assurance might be a possible use case, since you can inform yourself whether your customers like the product or what they don't like about it, or if there are any severe issues about it. So as key takeaway from this slide, we see that in many cases information is available online, but sadly this information is often in a human understandable format. So if we want to use it for further analysis, we need to transfer it to a computer understandable format, and this is exactly where the field of web scraping becomes relevant. So to get a better understanding of why we need to do some work in the field of web scraping, I will now show different approaches that have been presented in the previous years to the field of web scraping. On the right, you see a different representation of the same website. This is just as a hint to show that not all of these algorithms rely on the same input data. Some use the visual representation, others the HTML, and even others the tree representation of a website. So there are 4 different types of approaches to the problem of web scraping. We have structure-based approaches, for example, creating a template from a known website, and so next time we want to scrape it, we directly know where to find the information within the HTML document. There are content-based methods, for example, semantic web annotations, or simply looking for the largest body of text on a website. There are other approaches, for example, manual copy and pasting or reverse engineering HTTP requests. And there are already computer vision-based approaches, yet these don't solely rely on the visual representation, but they use the visual representation to calculate numerical features. These could, for example, be the location or size of certain HTML blocks, but it could also be their background color. With these numerical features combined, they can then calculate the likelihood for a content block to be relevant content. To some degree, the just presented approaches all have certain drawbacks. For example, the structure-based approaches can easily be affected by changes to the structure. So you update your forum software, and any scraping algorithm that previously performed quite well might now not work anymore. Same holds for the content-based approaches. I mentioned semantic web here, which sadly is not used as widely as it should be, so it can also not be counted as a generalizable solution. And in addition to that, different types of content, for example, a newspaper website, can be scraped differently than a forum website. The other approaches, so the manual copy and pasting, is also not very scalable. And the vision-based approaches that exist so far, like I mentioned, they do use the visual representation to calculate numerical features, but they do not solely rely on the visual representation. So they use these numerical features as additional input, but are still relying on the underlying HTML document. So as key takeaways from this slide, we now have seen that different approaches to web scraping already exist, which to some degree always rely on the underlying HTML. So this gave me the idea that we need a more generalizable solution, which might then only be vision-based, since we as a human, we will always be there to have a look at the website. So there will always be a representation of it, while the underlying HTML technology might maybe change. In addition to that, some websites might even look the same, so they could be solved with a vision-based approach, but the underlying HTML structure might be completely different. So when considering a solely vision-based approach, I had to find some inspiration on how to approach this issue. The ideas here came from the field of document layout analysis, so I'm shortly going to show two previous approaches in this field. The first approach was more relying on traditional computer vision methods, so it used technologies like feature detection to then detect areas of content, and in the second step, they then classified these areas of content. A more modern approach from 2019 was then using convolutional neural network-based detection. So they trained a model on manually labeled scientific papers, so that in the end the model was able to, when presented with a new paper, to tell you where is the title, where is the text, where is the image. And this basically gave me the confidence that it might also be possible to do web scraping solely based on the visual information, because here we have the key takeaways. If we look closely, there are some similarities between the field of document layout analysis and the field of web scraping. Because if we consider the website to just be a document, and that in the first step we are only interested in finding the locations of the relevant content, then these two fields are very much alike. Another takeaway we have here is that we've seen in the approach from 2019 that modern computer vision methods can achieve similar results than the traditional computer vision methods, which led me to the idea that we can have computer vision based web scraping. This brings me to the main idea of my conference paper, namely computer vision based web scraping for internet forums. I've limited myself to the subset of the internet containing forums, since as soon as we prove that the suggested approach is useful for one subset, we can then just continue to label training data for different types of content and hope that the approach also proves useful there. So mainly what I will try to do here is to use the approach to document layout analysis presented by Soto et al. In 2019, namely to train a convolutional neural network. This time I won't train it on scientific papers, which are manually labeled, but on screenshots of forums. Currently, there are already some possible advantages that we can assume here. These would be generalization and the robustness of the resulting model, as we will be using machine learning or deep learning technologies here, where it is not uncommon to sacrifice some degrees of accuracy and in return receive a model that is able to generalize better on maybe even unseen training data and even completely new forums. Of course, there are also some possible disadvantages that we can assume here. This would, for example, be the speed of the algorithm. So, of course, it is faster to just calculate some numerical features and use these to predict where to find the relevant content than having a convolutional neural network do the same computation. And additionally, of course, this approach is highly dependent on the training data. So this refers to as well the quality and, of course, the quantity of the manually labeled forum screenshots. So some key takeaways from this slide is that basically what I'm proposing in my conference paper is a knowledge transfer from the field of document layout analysis to the field of web scraping. Basically, it would be then an alternative approach to web scraping that solely relies on the visual representation. In the first step, we would then only be interested in identifying where on the website to find the relevant content, so that the actual extraction of the content can be left for future work. The last part of my presentation will be the proposed methodology. So these are the steps necessary to implement and test the approach of computer vision-based web scraping for internet forums. The first step along this methodology would be to select a suitable computer vision framework. My choice here will be for MM detection. The good thing about this is that it already implements most of the state-of-the-art algorithms for computer vision, so we can later then test which of the algorithms is more suitable for the task at hand. The next step would then be gathering and preparing the data. Here, my choice will be browser automation tools, for example, like Selenium, and labeling software, for example, like Label Studio. With this, it would be able to gather screenshots of websites and then, in the next step, manually label the data. This will be followed by the training of the model. So here we can consider things like pre-training, for example, on training data from similar task, for example, also training data from the document layout analysis task, and additionally also to consider pre-processing of the data. This will then be followed by experiments. Like I mentioned, these experiments could be regarding the choice of algorithms, so which state-of-the-art algorithm performs best for the task of computer vision-based web scraping. We could also test the speed of the algorithm to see how fast is it, and in the next step also how good is it, what's its accuracy on maybe threads from already seen forums or even completely unseen forums. The last step along this proposed methodology will then be the actual interpretation of the results. So depending on the results of the experiments, we might be able to derive some further insights. For example, which algorithm actually now proved the most useful, which pre-processing steps do we have to perform to make the algorithm perform better, or maybe which pre-training is necessary to also achieve better overall accuracy. Yes, some key takeaways from this slide. As you can see, all the tools necessary are already available, so it's quite easy to implement the proposed idea and to test it in further work. This is also what I will do in my master thesis, but sadly at the time of writing, no preliminary results are available. Yes, this brings me to the references and image references, and with that I want to end my presentation and thank you for your attention.
Hi, I'm going to present a work about comparative study between computer vision methods for the estimation and detection of the roadway. Let's show the outline of this presentation. Introduction, general approach to extracting road marking, road lines detection, experimental result, conclusion. Autonomous driving is a field of study that is progressing rapidly to answer road safety. Recently, researchers have been particularly interested in the detection of the roadway. Several new approaches have been proposed in the last decade. In this presentation, we present a comparative study of the roadway detection method using two algorithms: Hough transform, ransack algorithm, RADON transform. The objective of this work make a comparison of these methods with a view to robust estimation methods in computer vision. Apply the method of RADON for the detection of the roadway. Illustrate the general approach to extracting road marking. General approach to extracting road marking. This diagram illustrates processing methodology of the roadway detection and estimation method proposed in this work. Computer vision. The computer vision system is based in the processing of sequential sequence of digital image of the form of pixel taken by a camera raw information. Each pixel of the digital image represents information giving an indication of the amount of light and color coming from the surrounding space. Compared to grayscale, the grayscale conversion is pretreatment that facilitates the processing of the image that follows. Because the color image is composed the three layers red, blue, and green. But the grayscale image consists of a single layer of color, the grayscale. Apply Gaussian blur to reduce noise and detail. Smooth out the image before applying Canny edge detection, so we do not detect point edge. Canny's method is based in the derivation of variation to determine the image contours. It draws the edge with a big change of intensity, large gradient, and is displayed in the form of white pixel outline. The completely black areas correspond to a small variation of intensity between the adjacent pixels, while the white line represents a region of the image where the intensity varies considerably and exceeds the threshold. Region of interest. The proposed method determines the region of interest is based on the creation digital mask of the image. This mask consists two types: the pixels. 0 represents the black and 255 represent the white. A triangle pixel of value 255 identical to the region of interest that we are trying to extract, and the rest of the pixel have the value 0. The goal is to the end logic operation between the bytes of each pixel homologous to the image and this mask, thus masking the complex image to show only the region of interest corresponding to the mask. Road line detection. The main treatment consists in associating the control points determined from the region of interest to a model describing the limit curve of the road lines. To do this, we have used three methods, often stated to adjust control point to the model are Hough transform algorithm, ransack algorithm, RADON transform algorithm. The Hough transform algorithm based in the Polaris system used in accumulator matrix that represent the space. In distribution of noise points, each point becomes the sinusoid of the equation. As the figure shows, at the end of the accumulation, the sinusoid corresponding to the points of the same lane intersect at the point setting this line. The execution of this algorithm on the image of the region of interest, the accumulator corresponding to the vote which obtained the highest value of the parameter corresponding to the line of the contour of the roadway in the treated image. Probabilistic voting method ransack. The algorithm of this method is based on a number of iterations to reduce the calculation time of convolution voting methods such as the Hough transform. First of all, it randomly selects the subset of data to random points, then find the model for the selected data, then test all the data by model and determine the relevant points according to the threshold. If the new model is better than the base model based on the number of relevant points, then the new model becomes a best model. From the processes, the estimate preserves the parameters of the research lines. Ransack algorithm detects a road line after 12 iterations. The execution of this algorithm in the same image returns different results because it is based on the random selection of the data. All the results obtained are valid. Random transform is a mathematical technique. In general form, it is defined in a space of line according to two arguments, ρ and theta. The application of this transform in two-dimensional function is based on several projections of the image under parallel beams under different given angles. Calculate the line integral of this beam in the specified direction. The resulting image of the projection is the sum of the intensity of the pixel in each direction. Random transform it can transform lines into easy-to-serve pixels that correspond in the parameters of the line in the outline of the image. The property of the RADON transform allows users to detect 7 contours lines of the roadway in the image of the region of interest. Experimental results. Optimization algorithm. The detection of roadway contours by the two algorithms is robust, as well as the information of disposition of the lines of these contours. The information must be optimized so that to give a signal line in each limit of the road line. The optimization algorithm is summarized as below. After the optimization, we find a very important and valid result. As we show, the three algorithms is the same result. Experimental data. We have based in the error of the estimate of the slope and the interception of the detected line to prove the robustness of the presented algorithms. The error rate determined after a series of experiment values in acceptable y among the three methods compared to the real values. The method based in the raster presents a minimum error compared to Hough and random method, that the number of iterations that have been set so as to obtain a good compromise between the calculation time and the precision of the estimate. Conclusion. The comparative study has shown that the proposed vision algorithms of Ransack and Radon are robust to detect contour points and have a very efficient accuracy rate despite the fact that noise is present in the image. The Ransack method presents more efficient comparatively to Hough and Radon. The use of these methods is necessary to treat the region environment, but in terms of execution time is very important, which poses a problem of synchronization with the real time of a sequence of images. Thank you for your attention.
Good morning, everybody. Thank you for being here for my talk. My name is Shakib El Mouhi, PhD student on renewable energy at the National School of Applied Sciences of Ibn Tufayl University in Canny, Morocco. First of all, I want to thank the organizing committee of ICOA 2021. My presentation is entitled with optimal design of the cable layout in offshore wind farms using Firefly algorithm and minimum spanning tree. I opted for the next plan. I begin with the motivation of my interest and access of research, then the methodology of my work, then optimization of cable routing in offshore wind farms, and subsequently I give the results of applications of this algorithm on the wind farm, and finally the conclusion and future work. The wind energy is the fast-growing source of energy. The total new wind power installed worldwide increased by the rate of 9.6% in 2018 reaching the capacity of 591 gigawatt, and the global installed offshore capacity is 29 gigawatt. Therefore, it's very important to optimize the production efficiency in wind farms and to keep the power losses as low as possible. This can be achieved through an optimal cable layout design. This paper deals with the optimal cable routing of a power collection system in a large-scale wind farm, employing the combination between the Firefly optimization algorithm and the minimum spanning tree. A large-scale wind farm can contain hundreds of installed wind turbine generators interconnected through a medium voltage network or a power collection system, usually 33 kilovolt. In this way, the collected energy is transferred to the onshore main network over a transmission line. The collection system begins with every wind turbine that has its own transformer. Additionally, the collection system consists of several connecting cables or feeders. These feeders, which collect the energy generated by the wind turbines, are linked to the transformer substation. And finally, the transformer in the substation increases the voltage to a high voltage level for the transmission to the onshore mainland grid. So the main objective of this work is to reduce the total cable length and thereby the power losses and the investment costs, with a view to check the reliability of the proposed optimization method. This methodology is carried out on randomly created offshore wind farms. The obtained results show an improvement in minimizing the total cable length and, of course, cable costs using the Firefly optimization algorithm and the minimum spanning tree. For the optimization of the inter-array cable layout for offshore wind farms, we used a combination between the minimum spanning tree and the Firefly algorithm, and also the k-means clustering. The minimum spanning tree is defined in the graph theory as a subgraph of an indirected graph that comprises all vertices in this graph and allows only one path between each two vertices. The algorithm of minimum spanning tree can be projected onto an offshore wind farm in a manner that the wind turbines can be imagined as vertices and the cables connecting them as edges. In particular, the minimum spanning tree allows to represent the cable of the power collection system routed like the branched topology shown in the figure below. So for this case study, a set of 40 randomly generated wind turbines are considered on the surface of 20 square kilometers. The minimum distance between each two turbines is 560 meters, and the substation location is chosen to be in the middle of the offshore wind farm. The clustering with k-means was set to 5, which means that the total number of wind turbines is partitioned into 5 clusters, which in turn means that there are 5 cable branches to be optimized in the power collection network. The clusters of the wind turbines have in the diagram different colors. The total length of the cable within the power collection grid is, after use of the optimization approach, around 55 kilometers, and the initial length was approximately 129 kilometers as shown in the convergence curve. The reduction in the cable length and therefore the economic saving is 42.5%. As information, you can see the prices of 3-core submarine cables, which starts at 130 euros per meter and depends on the cross-sectional area of the cable. And the installation costs with the vessel is 250 euros per meter, which is independent from the cable cross-sectional area. You can imagine the huge price for the electrical installation of an offshore wind farm. So now to the conclusion, this article focuses on the development of an optimization algorithm for the cable routing of the internal power collector network within offshore wind farms by using a combination involving k-means, clustering, minimum spanning tree, and Firefly optimization algorithm. The power grid incorporates feeders connecting to offshore wind turbines as well as export cable, which transmits the generated energy to the offshore transformer substation. And for the validation of the reliable performance of the proposed optimization approach, the algorithm was evaluated on randomly created offshore wind farms. In particular, the algorithm is appropriate to get branched design topology. The obtained results are interesting and satisfying in terms of minimizing the cable total length required for the power collection network, which signifies economic savings in the whole investment cost already in the design phase of the project, and minimization of the power losses induced through the cables during the expected operational lifespan of the offshore wind farm. This work can surely be extended with an additional algorithm allowing the selection of the appropriate cross-sectional area of the used cables in the power collection system. Thank you very much for your attention, and your questions are welcome. Thank you very much.
Bismillahirrahmanirrahim. My name is Muhammad Ghulam Ghaus. I am the first author of paper ID 82. First of all, I would like to thank ICOA2021, all members who provide me this opportunity to share my expertise in the form of the paper contribution. And now I am going to prepare my video recording for your conference and IEEE. So let us start. My paper title is ICOA2021 128 and improved authentication encryption based on AEGIS 128. So here is the table of contents. We will follow one by one. So here is the cryptography overview. Because my paper belongs to the cryptography area, so I must define the cryptography at first. So cryptography is the method of protecting information and communication through the use of codes, so that only those for whom the information is intended can read and process it. So here is the hierarchy of the cryptography. Cryptography have the cryptography hierarchy has classical and modern. But my area is authentication encryption. So because in modern there are two, one is secret key and public key. In secret key we use a symmetric. Secret key means only one key can be used for encryption and decryptions. So in symmetric there are two type of cipher. One is the block cipher, second is the stream cipher. In block cipher there are so many algorithms, but I have selected the latest authentication encryption is block cipher is AE. So let's go and see what is AE. So here is the overview of the authentication encryption. This authentication encryption is a form of symmetric key encryption which provide confidentiality, integrity and data authenticity in one go. Means before the previous all encryption algorithm, they only do this encryption and authentication separately, but this is the latest algorithm, AE algorithm, which provides the encryption and authentication together. And because it introduced the MAC, message authentication code. Let's see what is the message authentication code. Message authentication code is a symmetric cryptographic primitives for providing message integrity protection. This mechanism can be used to detect any modification to a message occurring during the transmissions via communication channel. So this is the main thing. This mechanism used to detect the modification of the message. So here is the CSIR. Basically this CSIR stands for Competitions for Authenticated Encryption, Security, Applicability and Robustness. So in CSIR competitions there were 5 rounds, or in 5 rounds there are so many AE algorithms were participated, but AEGIS or few others would be the winner of every round. So I have selected the AEGIS algorithm because it is the fastest authentication encryption. So what is the AEGIS? So first of all, AEGIS developed by researcher from Nanyang Technology University by Singapore. It is the dedicated cipher. Do not use block cipher, stream cipher as a basic building block, but rather is use a message update the encryption state, and in the process message authentication is achieved for free. There are 3 main variants of AEGIS 120, AEGIS 128, AEGIS 256 and AEGIS 128L. So we have selected the AEGIS 128 because of it has the AES 5 AES round only. There are the other have 8 and 6 AES round, but AEGIS 128 using the less AES round, because my main purpose of this my main contribution of this paper is how to reduce the hardware complexity. So I reduce one AES round into 1/4 AES round. So that's why we have selected this 128 AEGIS. The problem statement, there are 2 major problems in the AEGIS. One is the weak state, because it use the all state is 16 bytes elements. So number 2 is the hardware complexity, because it uses the 16 S boxes for substitution, and number 2 the shift raw and the mixed column. So everyone is 128 bit 128 bit is the, so that's why we selected the AEGIS 128 and reviewed is its AES component. So my main objective is to how to implement the proposed algorithm in order to reduce the hardware complexity of AEGIS-128 algorithm. And number 2, to evaluate and compare encryption and decryptions of the proposed algorithm with existing AE algorithm AEGIS-128 against time, power consumption, processing time, processing memory, efficiency and performance. So here is some literature review, because I have studied different previous AES and the latest AE. What is the difference? So AE of course is one of the best encryption algorithm. Inside the AE we have selected the AEGIS-128. So after reading these all different encryption algorithm, we have selected the AEGIS-128. So this is my process, the research process, how I prepared my research process, and how can I select the AEGIS-128, how I propose my new algorithm. So here is the existing frame of AEGIS-128. So already have, because it has already run. So AEGIS-128 using AES round, or this AES round based on state and key. It has 4 stages for initialization, processing data, encryption and generation the tag. So in every state the AES round is used. In AES round the substitute byte, shift raw, mix column, add round key is used, and all OR is 126 bit. State is from 640 bits and the rest of all are 128. My proposed 1/4 round of AES, this is my main contribution, in which I use the multiplexer to convert 16 X boxes into 4 X boxes. To improve the AEGIS algorithm consists of the following 3 stages. First stage of the framework, we use shift row as a permutation, then you use multiplexer to use 4 S boxes instead of 16 X boxes. So this is my main contribution, to convert into 16 X boxes into 4 S boxes. So it will convert, it will also reduce from 128 bit to 32 bits. So here is the state inside the AES, the states, some changing. Number 2, no need to go for 16 times to fetch the data for substitution, only go for 4 times. So here I reduce 1/4 of AES round. So here is my framework of AEGIS-128. It has also same 4, but inside we not use for 128. Here I am using is 4. 4 means 1/4 AES round. So in initialization, processing, encryption and tag generation in all. So here is fully framework of AEGIS-128. So here is my main contribution is this area. This area is my main contribution by using 9 multiplexer to give the input state input values, and then M10 give the value for a state update method. So this area is fixed for the ciphertext and the tag. Only my contribution of this area and this area by using the different type of multiplexer. Here the decryption and encryption in AEGIS. The one thing is very interesting in AES and the other previous algorithm. If you do the encryptions, so you must do the decryptions. You use the inverse box, S box, inverse shift raw, inverse mix column. Here no need to go for inverse. Just change plain text into ciphertext and ciphertext into plain text, and just repeat the same steps for encryption and decryption. So here is the algorithm for my learners, step by step. So how I use this algorithm. So how I design this algorithm for state update function, initialization of the AEGIS, or the processing data of the AEGIS, encryption AEGIS, and finally how to generate the tag. So these all by following of these algorithm, the learner can run the program and encrypt the data for fast authentication very easily. Here is my experimental results. So in my experimental result, we use C and C++ and VHDL language. So, and we have selected the three different size of file, 100 kilobyte, 450 kilobytes, and 105 to evaluate metrics, encryption time, decryption time, throughput, and processing data by having the hardware Intel Core i7 or 16 GB of RAM. So this is my main contribution here in my paper. I mentioned the definition, the formula, how I measure the time, encryption time, decryption time, throughput, processing memory, efficiency, and power analysis. So this will very helpful for every learner and user. So here is my result and discussions. In my result and discussions, you can see we have taken the average value of the encryption time, decryption time, throughput, and the processing time of that three different size of file because we apply my algorithm for 100 KB of message, 450 KB of message, 1024 KB of message, and after that we took out the result, an average. So here is the average is 25.62, and AEGIS take only for 6.4 for second for encryption and decryption and throughput and different. So you can see here is a graphical representation. You can see the less encryption time, decryption time, throughput, and the processing memory. Here is the hardware efficiency. You can see the Hough and after using my proposed algorithm, how the throughput and area can be compared to the existing algorithm. So it is prominent. It is very prominent to identify the difference between the AEGIS 128 and ICOA 128. The power analysis. In power analysis, we also, so this is not only for the high processing, it also use the low power. This means that if you use this encryption in the mobiles, so your battery consumption time of course will be better than the other encryption time. So I applied this power of 120, 400, 450 and 102 kilobyte and got this result. So you can see and compare. So the conclusion of this paper, the performance evaluation of the AEGIS 128 proposed AEGIS algorithm, the new transformation within the AES component and reduce the hardware complexity. The ICOA 128 is faster than AEGIS 128 in terms of execution time than AEGIS 128 based on number of rounds. Throughput varies inversely to the encryption decryption time, and power consumption is less due to the reducing of AES round. So ICOA 128 has more throughput than the AEGIS 128 algorithm. The overall performance of ICOA means my proposed algorithm has been proved successfully. So here is I successfully accomplished my objectives. My both objectives I got the results and accomplished by successfully. Here is my contribution in two parts. The first part is introducing an improved method of AEGIS 128 in combination of AES round component is update to mitigate the issues of the different attacks and to modify the component mathematically proved and tested in different aspects with the method. Number two is based on the proposed algorithm, full AES round is modified into 1/4 AES round function, the reduced hardware complexity which is provided the best performance during the encryption process. This is my future direction. In future, this encryption algorithm can be used for image, audio and video data type, and at last I used different references. I collected different informations, the challenges or the problems and solution by different paper, and also add my contribution of this paper. At the last, I say thank you from my all authors and from my university and from my departments. Thank you very much. once again to having this opportunity to explain our expertise and contribution with you. Thank you very much. Assalamu alaikum.
Hi everyone, my name is Hamid Wulsidi, Doctor in Applied Mathematics. Today, I present to you a presentation on multi-objective design optimization using flower pollination algorithms. The plan of this work is as follows. We start with multi-objective optimization. And then I will speak in a very summary way the flower pollination algorithms. And then I will give the algorithm that we are going to propose. Multi-objective optimization using flower pollination algorithms. Then we will give some numerical results. And I will end this presentation with a conclusion. The multi-objective optimization. What is optimization? The optimization tool aims to determine the minimum of a function, or maximum of a function to get the decision maker to a profitable choice. The problem is written mean and function f subject to the constraint xli gg each k. If m equal 1, this is a single length optimization problem, mono-objective problem. If m superior strictly to 1, this is a multi-objective optimization problem. The recent years, artificial immune system AEGIS, a new algorithm have been proposed to improve convergence speed and up diversity of multi-objective problems. Main strategy based on multi-objective immune algorithm, MOIAS, promising performance in solving multi-objective problems. For example, NSGA2, NNIA. For the flower pollination algorithm. Flower pollination algorithm FPA, a new nature-inspired algorithm is proposed for solving mono-objective optimization problems. The following 4 roles are used. The role 1, the biotic and cross-pollination can be recognized as a global pollination and pollen-carrying pollinator move in a way-wish obeys Levy distribution. Role 2, abiotic pollination and self-pollination are used as local pollination. Role 3, the flower continuous property can be considered as the reproduction probability is proportional to the similarity of 2 flowers involved. Role 4, the local pollination and global pollination is controlled by a switch probability P in 0, 1, slightly based towards local pollination. The algorithm, flower pollination algorithm. For the multi-objective pollination flower algorithm. In this part, we present an improved FPA called multi-objective flower pollination algorithm, MOFPA. In our MOFPA, we adopt the non-dominant sorting concept used in NSGA2 to select the individuals in the better fronts in order to push the population towards PF5. The mechanism of crowding distance to maintain the diversity of the current-based solution in the XML archive. The algorithm of multi-objective flower pollination algorithm. The MOPFA algorithm is given by the following instruction. With n is the number of variables, and m is the number of objective functions, and f is the function that we want to minimize, and max g is the generation numbers, and we have x max and in x min. The first step of the first step is for this population we look for the non-dominated points, and of course we apply distance crowding. We apply the crowding distance to find the best non-dominated points. Now we start the next generation. On the population of points we apply the PFA algorithms, and then we apply the objective function to the new population XP chapel, and therefore we find the population X3 chapel. On X3 chapel we look for the non-dominated points and we apply the crowding distance, and we repeat this until T equals max G. For the simulation results and analysis, the performance of the proposed algorithm is tested on a set of live and constant question mark problems. The function ZT1 is the function with no convex, and ZT2 function with convex, and ZDT3 the function with discontinuous, and ZDT3 is the function unconstrained, generally used to validate the performance of different multi-objective evaluation algorithms. The parameters of multi-objective flower pollination algorithm are fixed. The population size n equals 100, and beta equals 0 to 0.25. The number of iteration t equals 250. The function ZT1, ZT2, ZT3, and UF1. The Pareto the Pareto fronts for the four functions are as follows, compared with their original fronts. The graph of the function ZT1, ZT2, ZT3, UF1. The following table presents the comparison between the distance generation for algorithm in literary such as the comparison of generation distance. We notice that our algorithm is closer to 0, MOFPA. We notice that our algorithm is closer to 0. For the design optimization, in this example, we deal with the disk brag design problem. The mathematical formulation of the problem is as follows. Minimizing the function f1, f2, subject to the constant c1, c2, c3, c4, c5. The plot in figure 2 show the approximate Pareto front obtained by two algorithms on each of the disk brag design problem. Then algorithm multi-objective pollination flower algorithm generally yields better approximation of the Pareto fronts. For the conclusion, the multi-objective pollination flower algorithm shows the best Pareto optimal fronts obtained by our proposed algorithm on the flower benchmark functions, in which the shape of the Pareto optimal fronts convex, non-convex, discontinuous. And the multi-objective flower pollination algorithm both provide a very good convergence toward all the Pareto optimal fronts for our mission mark function, compared with the algorithm NSGA and MODA. Thank you for your attention.
Hello everyone, my name is Sayan Roy. Hope you people are doing good in this current COVID situation. Today, me and my co-researcher Binoy Sasman would be discussing about our paper, Integration of Hierarchical Clustering and Dendrogram Method with Expectation Maximization for Identification of the Best Player Cluster.
Let's get started with the introduction part. As more and more computer power become available in the past decades, computing statistics using large amount of data became more mainstream. This rise influenced the use of data science within the field of artificial intelligence as one of the strategies in optimizing data variables. Over the past years, we also see more and more machine learning techniques have been applied to sports data. Clubs started analyzing their players using statistics and using machine learning techniques to maximize player performance, and sports data analysis can vastly improve team performance and help coaches make the right decision. In this paper, we have compared two machine learning clustering techniques on football data, hierarchical clustering and expectation maximization. We will determine which technique cluster the data best using two cluster evaluation method, purity and the silhouette score. Next to that, we will calculate the best cluster size and see the best way to separate the data. At last, we will determine the best and worst features in our data for these clusters using the silhouette score, Laplacian score and the correlation mean. Coming to related works, previous work within the field of football analysis dominantly contains paper with supervised learning methods. In Decruz's work, individual players are analyzed using similar event dataset in comparison to our to determine the overall strategy the coach imposes on the team. Instead of single events, it calculates event streams and deduces phases during a football game. Work by Liu et al. Focuses on classifying players from a video stream of the match. It also uses expectation maximization clustering. Liu uses expectation maximization on different types of player images and overcome the problem that in dataset not every player cluster has the same size. Study by Mahfouz et al. Focused on unsupervised learning techniques used in this paper. Mahfouz primarily used k-means and expectation maximization to do overall analysis of the player performance. The analysis was focused on the training data and drills, did not include any matches. Study, however, fails to draw any notable conclusion. Overall, we can conclude that related work is dominantly based on supervised learning. This thesis will fill gap here and contribute the research on applying unsupervised learning techniques on event data of football matches. Now coming to dataset part, we use two different dataset in our research. One is StatsBomb and the other is FIFA dataset. StatsBomb contain a sample of 809 matches, all of which from the Spanish football competition La Liga. For each match, it defines what sort of event happened in a match, such as passes, shots and dribbles. From 809 matches, we used 452 matches. In those 452 matches, 1.6 million events have happened, on average 3,559 per match. We again cleaned the data such that the column we are using in the end consists of player, position, location, type and related events. The FIFA data originates from the EA Sports game FIFA 19 containing 89 columns, 80,206 rows with players and their attribute score. We analyzed way in how we could correlate both data to discover what insights we could receive. Methodology. In total, we have used two unsupervised clustering methods, namely hierarchical clustering and Gaussian expectation maximization. We also used principal component analysis for visualizing the data. At last, we used four scoring methods for evaluating purposes: purity, silhouette score, Laplacian score and correlation mean. We use purity for knowing how good a cluster performs and uses the actual levels to calculate the correlation between the predicted and actual levels. We use silhouette analysis for predicting best algorithm as well as calculating the best cluster size. Silhouette analysis calculates how similar data is to data in their cluster in comparison to data in other clusters. Continuing to slide 6, We use PCA to visualize the data from 23 dimension into 2 dimension to plot it in a scatter plot. To verify the results of column and feature selection we have done with the silhouette score, we use a method that focuses on identifying good and bad feature in unsupervised data, named Laplacian score. Laplacian scores score features based on how they preserve each cluster. They seek which features are best in containing two close data points close. Laplacian score use a graph where nodes are data points and edges of each node are its nearest 5 neighbors. Based on the Euclidean distance between the two, we define a weight matrix based on this graph measuring similarity between each neighbor if two nodes are connected.
The data we analyzed is 25-dimensional. To visualize this data, we used PCA to reduce the dimensionality to 2 dimensions. For the first clustering task, we set the number of clusters to 4. The number 4 corresponds to the different groups of positions in the football field, namely the position of goalkeeper, defender, midfielder, and forward. In the figure, we can see that the data clusters do overlap, except for the goalkeepers. An exception for this is that goalkeepers tend to stay in one location and tend to have quite different action in comparison to the other players on the field. In these figures, we can see hierarchical clustering and expectation maximization algorithms. In both methods, we used 4 clusters as we tried to model the cluster of the 4 positions on the field. We trained both methods on all the data with 30,000 iterations. We see that the hierarchical clustering algorithm tends to keep the cluster size the same. The expectation maximization algorithm, however, tends to cluster most of the data in one group. According to the purity score, we can see that hierarchical clustering does a better job at classifying the right cluster in comparison to expectation maximization. However, the silhouette score is close to 0 and suggests it might be better to take different number of clusters. Next up, we use a higher number of clustering, which is 11. This number of clustering corresponds to the number of positions of players on the field. We trained the model on data and again used 30,000 iterations. We visualized the data in 2-dimensional using PCA first, as shown in the figure. We see that there is almost no separable data except for the goalkeeper, which again do have their cluster. In these figures, we can see hierarchical clustering and expectation maximization algorithm with 11 clusters. We can see that expectation maximization tend to cluster the data somewhat better than with 4 clusters. Next to that, we again see in expectation maximization that some clusters are way more extensive than others. Both the purity and silhouette scores are in all cases way worse than using only 4 clusters. We can see that individual players' positions are not clusterable at all. The data does not differ enough between the different clusters to separate the player into position categories. We now know that hierarchical clustering is better algorithm. We also know that 4 clusters work better than 11 clusters. For every number of clusters, we train the model and calculate the silhouette scores. We see that cluster size of 8 has the highest silhouette score, meaning 8 clusters do create the best cluster where each cluster is most apart from other clusters. The main finding of this study were that the amount of 8 clusters best separate player types. With the use of silhouette analysis and hierarchical clustering, we saw that all other cluster sizes scored worse separability of different types of players. From this, we can say that given a football match, we classify each player performance as either one of 8 types. Thus, there are only 8 types of players in a football game. In contrast to 11 or 4 player positions, we conclude that some positions within football are redundant or perhaps versatile. From our PCA visualizations, we see that goalkeepers are uniquely defined and do not correlate with other players in the field. We see that the cluster size have about the same size according to the labels. Expectation maximization tend to neglect evenly sized clusters, and this might have influenced why we saw hierarchical clustering outperform expectation maximization. Hierarchical clustering was able to classify 66% of the data correctly when using 4 labels. With the use of feature selection, we see that we can increase the performance of the hierarchical clustering algorithm by 37%. This score indicates that feature selection is essential when fine-tuning a model, whether supervised or unsupervised. Prior studies also tell us the same. The scientific conclusion is that fine-tuning parameters and feature selection plays a significant role in changing machine learning algorithms to adapt to specific problem domains. Thank you.